Hello everyone, welcome back to my channel. My name is Piyush and this is video number 9 in the series CK 2024. In this series, we'll be looking into services like different services we have in Kubernetes such as ClusterIP, NodePort, external names, load balancers and so on. And we'll also be looking into namespaces. So the target for this video will be as follows. So I'm expecting at least 120 comments and 250 likes in the next 24 hours. It's gonna be an easy target for you. I'm sure you can do it. So yeah, without any further ado, let's start with this video. Alright, so in the previous video, we have seen replica sets, replication controller, and deployments. So this is what we had earlier. We had a deployment with 4 pods running that is serving Nginx as a front-end application, and it was running on multiple nodes. Now, this deployment, we mentioned this as well, that this deployment is not yet exposed to the users externally. We can only access the pods inside this deployment by accessing the nodes or from the cluster only. So how do we make sure that, because this is a front-end application, how do we make our front-end application available? We do that with the help of services in Kubernetes. So let's take another example. So let's say over here we have our application running. So consider this as a deployment or even a single pod, that doesn't matter. So this is our front end application, right, which is running on a container on a pod. And we have backend as well, which is a Node.js application. And we have an external data source, which we use to get some data from our backend access this external data source to get some data. So how do we make sure that our application is accessible to the users? And how do we make sure that our pods are able to communicate with each other at different layers? Like our front end pods should be able to communicate with the backend. Our backend pod should be able to communicate with the external data source. How do we do that? We do that with the help of services. So between that, we'll add a service over here, right? And we'll look into different services as well. So we access the service, and then that service will then request the front end pod on which the service is exposed, and it gives the response back to the user. The same way, this service will be then used, or any other service will be then used to access our front end to the back end. And the same way, this service or any other service that we have will be used to get the data, or write something to our external data source. So this is how it will look like. All right, so our service makes our application loosely coupled. It makes sure that our pods are listening on a certain port and accessible to only what we have specified, right? So for example, this is a front end application, so this should be accessible outside the cluster, outside the node, publicly to all the users. So we'll be exposing this on, let's say, port 80 or port 443, and that service will be listening on that port. Let's have a look at another example. So we have different services in Kubernetes. We have, I'll just write it down over here. We have ClusterIP, then we have NodePort, we have external names, and we also have load balancers. We'll look into each one of those in detail. Okay, so these are all the services we have in Kubernetes. So first, let's look into the NodePort. So as we mentioned, like in the previous diagram, we had multiple services and multiple pods running on multiple nodes, and it works the same way for a single pod, for a single node, or multiple node, right? So let's say we have a pod running, it's a front end pod, and we have to expose it to the external users. So the first one, the first service that we'll be looking into is NodePort. So this is a service on which the application will be exposed on a particular port, and that port is called NodePort. So let's keep it over here. Let's say we expose this application on port 30,001. Okay. Why this number? Because the range for the node port is from 30,000 to 32767. So we have to specify a static port between that range, right? So our application will be listening on port 30,001. All right. And then our service will be exposed internally within the cluster. That means all the service that are internal to the cluster will be accessing this particular port on a certain port. So let's give this a port as 80. All right. So this is our internal service port. And we have another port on which your application will be listening. So we call it target port. So let's say this is also 80. Now let's understand the difference between all the ports that we have specified. So we have a target port. Okay. And this target port is the port on which our application pod is listening on. This is not exposed externally, and we have exposed this one externally over here, right? So this is your NodePort. So NodePort is something that is exposed externally, and then it redirects the traffic, or it forwards the traffic from port 30001 to this target port 80, right? So this is your target port 80. And I'll change the line to this as well. And this over here is your port. It is referred to as port. And this port, as I've mentioned already, that this port will be used for the other services or other applications that are running in the cluster in the node. So this is your internal port that other ports will be referring to, right? So if I am an external user, if I am accessing this application on the web, on my browser or from my local system, I will access that on port 30001. But our application is listening on port 80, which is the target port. And if I am a pod that wants to access this particular front end application, let's say I'm a backend pod and I want to access this application, then I will be using this particular port, port 80. Currently, these two are same, but these could be different, right? If you don't specify any of these, so by default, it will take port 80 as because this is the same port that we had, right? Now, I hope all the difference between these three terms is pretty clear: node port, target port, and just the port. And when it comes to the service, Kubernetes service point of view. So let's move on. And yeah, so as I mentioned, like it works the same way. Let's say we have multiple pods running on multiple nodes. So over here, we only had one pod running on a single node. But let's say we have multiple pods running on multiple nodes, or multiple pods running on the single node. Whatever the case is, the service will be exposed the same way, right? So this service will be accessible to this port and on the same port, say port 80. This is your target port, port 80. In this scenario, when we request the service, now because these are multiple pods behind a deployment, so we will be, using the IP address of the node. Okay. And let's say we have to access this port, then we'll provide the IP address of this node, and then colon 3001. So it will redirect the traffic on a round robin basis, right? So the traffic will only be accessible on this particular port from outside the cluster. And then the service will then internally load balance the traffic between multiple nodes and multiple pods that are behind the service. Okay. So I guess we have learned enough about the NodePort service and what service actually does. So let's go to our console and let's try to implement a service. So here is my VS Code editor, and I'm in the day 9 folder. Let's see what we have already running. We have, I guess, 3 Nginx pod running behind a deployment. So let's use the existing ones and let's try to create a service. Okay, so in the same folder, I will create a new file and I'll call it nodeport.yaml. I'm going to create a service and I'm going to expose this application on port 80 outside with the node port 30001. So again, same 4 fields. So we have API version, we have kind, metadata, and spec. Now let's check the version. kubectl explain service or SVC, right? So it's one and the same things. That's service. Okay, so kind is service, version is v1. So I'm gonna use that v1, and kind is service with a capital S. So remember, this is case sensitive. Now inside metadata, we can specify a name and label of the service. So let's give this a name, NodePort SVC, and let's use the labels env demo. Okay. Inside spec will specify what type of service it is. It could be a NodePort, load balancer, cluster IP, and so on, right? So we specify the type, service type, and then it's a NodePort, right? And now we specify different ports, and this is a list. This is an array. So make sure you do use the hyphen sign with it. So we have NodePort, which is 30,001, one more zero. Okay, 30,001. Then we have port 80 and target port, which is also 80. I guess this should be capital P. Let's see if we have done it correctly. I'll just cross verify it from the documentation. So we have our service. Let's search service over here. There won't be any sample YAML on this quick reference guide. So I'm going to search service over here. And on the first result, let's see a sample YAML. Okay, so we have metadata, kind, name, that's okay. Then we have selector, that's fine for now. And then we have ports. So we have protocol, port, target port. Let's see another one which has a node port as well. Node port. All right. So type is node port and port is 80. So it is ports, not port, and then target port, and then node port. So spec type is node port, that's fine. Okay, so there is another field which is ports. It shouldn't be inside this. So it's like this. Type is node port. Okay, and then at the same level have ports. So node port, port, and then target port. I guess this is fine now. Port, target port, and node port. Port, target port, and node port. Okay, this is good. Now we have one more field which is selector, because how do we know, or how would service know that which pod or which deployment to be served as the service, right? Which has to be exposed. So on the same level of type, inside spec, we specify selectors. And then we specify labels over here. So let's see what labels our pod has. So when we did kubectl get pod, it was not showing us the labels, right? So we add one more flag, which is show labels, like this. And now it will show you the labels. So label is env equal to demo, right? So that's a label that we need. Inside selector, match labels, and then env demo. Okay, now save this and let's hope it works. Create -f nodeport dot. I'm not in the correct folder. A09 services. Now kubectl create -f nodeport YAML. Okay, it says cannot be handled at a service. There is something wrong at this field. Service spec.spec.selector. Selectors, match labels, env demo. Let's see what mistake we did. So it has to be selector, and inside that Okay, I guess we don't use match labels. We just directly specify the label. That's what it feels like. So let's try to use that. Let's remove match labels. Okay, save, and let's run it again. Okay, it says unsupported value. The supported values are ClusterIP, external name, load balancer, and NodePort. NodePort with N capital and P capital. Right. So as I've mentioned, it is case sensitive. So make sure you use the format that is accepted by Kubernetes. Okay, I have made the change. Now it should work now. Okay, it says as invalid because invalid value 30,001 is not in the valid range. Valid range is 30,000 to 30,000, 32,767. And what did we use? 30,001. So why it is saying it's an invalid, or maybe I added one more zero, one extra zero. Yeah, I added one extra zero. So 30,000, that's not 30,001. That's all right. So now it should be correct. Okay, now it says service created finally. So kubectl get svc or get service, one and the same thing. Now this one cluster IP, we already had it earlier, and this is what it created, NodePort svc, and this is the IP that it created, and it is exposed for target port 80 and the node port 30,001. So now our application should be accessible. So we need to get the IP of the pod. So get pod -o wide. Let's take any one of those. So I'll take the IP 10.24.161, or it has to be the node IP. I'm not sure. Let's try with this one. Okay. So IP and then 30,001. Okay, I guess not this one. It should be the node IP because that's where your service is running. So instead of that, we do kubectl get nodes -o wide and okay, 172, 180. This is the control plane node. Let's see where our pod is running. Okay, this command does not show where our pod is running. So kubectl describe pod and then the name of the pod. Okay, over here there'll be a field which says node. Okay, let's see. Okay, over here node is this one. I'm just gonna copy this IP and then 30,001. Even though we have made the changes, even though we created the service, our service is still not accessible over port that we have defined. So I guess it's time to read the documentation. So let's go back to kind cluster, because the way we have created the cluster, if it would have been a Kubernetes cluster, any other on-premises cluster, or like let's say in your exam, then this should have been working till now. Like there is no extra step for that. But because we are using kind, and the way it works is in kind cluster, it does not expose your port to the outside world, right? So that's why we have to do an extra step just for the kind cluster to do the port mapping. So if you go down to the documentation quick start guide of the kind cluster, and this is what we follow to create the cluster, right? There is one extra step over here in which we add the container mapping, port mapping, right? So if you go down, it says mapping ports to the host machine. This is what we use. And it says this can be useful if using NodePort services or daemon sets exposing host port. So yes, we're gonna add this particular, yeah, these three lines in the control role. So that's how it will expose it locally. That's how our application will be accessible. So we might have to create a new cluster because we cannot change the existing cluster in kind. So let's go back. And we had our YAML file for the kind cluster somewhere. Yes. Okay, let's create one. Yeah, we don't. Yeah, I might have deleted it earlier. So let's create one so that it will be helpful for you. So kind.yaml. Okay. And in that, first we'll add the other details, this section. And this is the same YAML that we have used earlier while creating the cluster. So in video 6, when we provision the cluster, we use the same YAML. Now we're just adding one more field to it inside roles. So let's go back and add this one. Okay. Now we want our application to be accessible over a container port 30,001. So this is what we'll be using over here. And you can add multiple ports as well. For example, you want to expose some application externally on port 80 or 8080, then you can add those. But for now, 30,001 is what we need. Okay, save the file. Then we'll be running the kind create cluster command. So kind create cluster hyphen config equal to kind.yaml, and then name of the cluster, let's call it ck cluster 3. And what else? Let me see if I'm missing something. Um, okay, create cluster, name, and config YAML. I guess that's all about it. I'm just checking the syntax if it is correct. Okay, hyphen config and then the YAML. Okay, so let's go back. Okay, it says cluster with that name already exists. We don't need the existing one. Let's delete it. Delete cluster AA the 3. It might free up some resources. So grind unknown command, delete kind delete cluster, and I guess hyphen name. Okay, yeah, this is the one. This is the extra step that we are doing, right? If you are on your exam lab, or if you are doing this on on-prem server or cloud server, you don't need this extra step. This is just for the kind cluster that we have to recreate the cluster with the port mapping. Else, till here, so you create the deployment, you create the service, and that's all about it. Your service should be accessible on the node IP colon your node port. That's all about it. But this is just because we are doing the demo, so we want to make sure that we complete our demo and not just do the way it used to be. So that cluster is deleted. Let me create the new cluster. Okay, it might take a few seconds. So I'm gonna pause the recording till then. All right, so our cluster is created now, and it by default would have switched us to the cluster, so we don't really use the use context command. Let's clear the screen and let's see kubectl get nodes. We have 3 nodes created. Now we're gonna create the deployment. Let me use the existing YAML that we had in the previous video. So kubectl apply -f, and it was in day 8 folder, A08. The name was rc.yaml. Apply it. Okay, let's see what was there in that file. So in rc.yaml, we created one deployment with the name nginx-deploy. It has one label, env demo, and there was a container with nginx latest image, and the port was exposed on container port 80, 3 replicas. All right. So that's what we did. I've applied that YAML. The port should be up and healthy now. So get pods or PO. Yeah, three pods are running. Now we have to expose this via NodePort service. So for that, we had this NodePort YAML that we have already seen. Everything remains the same because we are using the same label and NodePort 30,001. target port and port 80. That's good. And selector is the label of the deployment. Okay, let's apply this file as well. kubectl apply -f nodeport.yaml, and this is also created. Now, if you do kubectl get svc, here is a service, NodePort service running on these ports, and you can also run describe on this service. It will show you a lot of other details. kubectl describe service NodePort -svc. So it shows you that its name is NodePort service. This is the label. Type is NodePort, and IP is target port, NodePort, and so on. Right? It shows you all the details. Now, our main goal is to make the service accessible over port 30,001. So now if you do a curl on localhost :3001, we are getting the reply, welcome to Nginx. You can try it from your browser as well now. So instead of the node IP, localhost 30,001 and welcome to Nginx, our web page is now getting loaded. So just a quick recap. What we did, we recreated the cluster because it is the kind cluster. Kind cluster does not expose the node port externally. So that's why we had to do a little tweak. We created one more file, one kind cluster YAML config file, right? Earlier, we only had, when we created the cluster, we only had this part, right? One role for control plane, two role for worker nodes. Okay. And now we added this part which says extra port mapping on the container port 30,001 to the host port 30,001. So that will expose your container port 30,001 externally on the host, and through which you can access your application running on the local host. All right. So this is the extra step that we did, and then we created the deployment, and then we created the service. Your service is now exposed. But over here as well, you have to remember this in exam or when you are running your cluster not on kind, let's say on premises or any other cloud. By following the steps that we did, your service should be accessible on the node that it is running. For example, if you do kubectl get pods, it describe any pod, kubectl describe pod. Okay, I made a mistake. Okay, and go up, check on which node it is running. Okay, 172.18.023. So by default, your application should be accessible on this IP and this port. But because this is a kind cluster, it is exposed on localhost. That's the only difference, and this is what you need to remember. Right, so this is what we wanted to cover about cluster. And there is one more thing. There is, because you are like I have to type some commands a lot of time, so it's a good habit to set this as an alias. So what I'm gonna do in my current shell session, or maybe I'll add this in my bash profile as well. So if I go to my home directory and bash profile, I will add one environment variable, which is alias k equal to kubectl. Okay, I guess it should be in single quotes, if I remember correctly, but let's see. Now, if I source my bash profile, okay, and if I run k, so k will run now kubectl whenever, let's say, if I have to do get pods, so I can just do k get pods. Now I don't have to type entire kubectl again. So this is how you can set some alias to make your work easy in your local environment, in your local session. But for the exam, you don't need to do that. And there are some bash completion commands as well given in the cheat sheet that you can also refer. For example, if I go over here, okay, Control F. Okay, so if you run these commands. So this will add some short alias to set and show for workspace, and it will work on bash and bash compatible shells. So you can try these out as well. Okay. Yeah, and run this. It will help you with the auto completion with the tab. So this is what we did already. We set the alias, and if you run these commands, this will help you. With the help of a tab, you can auto complete the command. Right? It'll be really helpful. Okay, so yeah, so this is what the NodePort service is about. Now let's have a look at the cluster IP. Let's say you have an application like with front end, back end, and database. In front end, you have multiple pods running. For example, Nginx pods. In backend, you have multiple pods running for Node.js, and then you have database such as MySQL or Postgres, whatever. Now, your application has to interact with each other. Like these pods should know each other's address. Like how would they communicate with each other? Yes, there'll be an IP associated with every pod, right? So there'll be an internal IP associated with every pod, but that IP is not static. As soon as the pod restart, the IP gets changed, right? So let's have a look at this one. So if we check the IP of this particular pod, kubectl describe pod, and then this one, let's have a look at the IP. Okay, the IP is 10.244.1.2. Let's delete this pod, kubectl delete pod. Okay, I have just deleted it, and kubectl get pods. Now the pod that gets created is this one. So if we do kubectl describe pod, and now if we look at the IP, 10.244.2.3, right? Earlier it was 10.244.1.2. So IP has been changed as soon as the pod restarts. So that's really not the way of how you would want to communicate with different pods and services, right? This IP is not static. So how would you make sure that your pods are accessible on a name or a certain port by other services? Like if your backend has to communicate with your front end pod, how would they do that? So this is where cluster IP come into the picture. Okay, so we create something called as a service of type cluster IP. Okay, and then your Nginx pods, your front end application should be able to interact with the backend application. So like this. Okay, that arrow doesn't like me, so that's fine. And like this. So this particular service, this particular cluster IP has the endpoints as these two pods. So you can access these two services or these two pods using the cluster IP name, the service name or the IP of the cluster IP. So when we go back, okay, and if we do kubectl get svc, so you see the cluster IP, the default one that gets created for you as the cluster IP of this. So you can access this cluster with this cluster IP or its name. So name is Kubernetes, which is the default one. So you can create your own cluster IP. So with NodePort is basically we expose it on a certain port, but cluster IP works on port 8443 and HTTP, HTTPS ports. And this is how your different services and different components interact with each other within a Kubernetes cluster using service IP. And let's have a look at how do we create one cluster IP. So I'm just gonna copy the content of NodePort YAML, and I will create a new file inside this, and I'm gonna call it clusterip.yaml. Okay, paste it over here. Now most of the things remain the same. It should have a selector, and the type should be cluster IP. Okay, so type is cluster IP, or default service type is also cluster ID. So if we even you remove this field, then also it will create a cluster IP. So let's remove this, And now we don't need the node port because it will be accessible on the port itself. So we only need port and target port, and that's all about it. Rest of the details will remain the same, like it will have a selector which will select the deployments to be exposed as service. Okay, and yeah, type should be service, and name you can give it the name of your cluster IP service type. It's safe. If you do kubectl fly -f cluster ip.yaml, say service created, kubectl get svc, and now over here you will see a new cluster IP has been created. Earlier we only had these two. Now it created one cluster svc, and this is the cluster IP. It doesn't have an external IP because cluster IP is internal to the cluster, so that other services, other pods can refer to this particular pod or service. And it's currently exposed on port 80. This is what we did, and you can do a kubectl describe. Remember we set the alias, so I can use K as a short for kubectl. So describe svc slash cluster svc, and now you will see cluster svc as the name. We have an IP assigned to it, target port, and then we also have endpoint. So endpoint, I guess we missed explaining this term. What is exactly the endpoint? So endpoint is nothing but the IP of the pods on which the service is listening to. So if we do kubectl get pods hyphen o wide, right? So these three pods have IP 10.244 2.3, 10.244 2.3. Here it is, 10.244 2.2, 10.244 2.2, and 10.244 1.3. So these three are nothing but the IP addresses of the pods. Whenever there is a pod restart, that means a new IP gets assigned to the pod. This endpoint will also be updated over here in the service, and it is listening on port 80 because that's what we said. And you can also check the endpoint from kubectl get endpoints or get ep, right? So here are our endpoints exposed to this cluster service. This is what we just created. Then this is your IP address of the cluster, and then this is your node port service IP addresses. These two are the same because we created the service, the node port service and cluster IP service against the same deployment. That's why these two endpoints are the same. All right. So I'm just gonna clear the screen. And this is what basically means cluster IP. Like this is how cluster IP works, and this is how we use it. Okay, so now we understood NodePort and cluster IP. Now let's have a look at the third service type, which is load balancer. So let's say we have an application, as I've provided the details earlier as well. Like every pod has a dedicated IP assigned to it, and when the pod restarts, the IP gets changed. So we cannot really access the pod from its IP address, not even internally, because the IP is not static. It is changeable from time to time. So we need something that stays persistent throughout the life cycle of the cluster, and it's something that doesn't change. So that is why we use service. Now there could be, like, if in this example, let's say there are different IP addresses assigned to each of the pods. Let's say 172.168.9.1, and it's exposed on port 30,001 to the external users, and we have three different pods running, and let's say if they are running on three different nodes, so these IP addresses will then be changed to 9.2 and then 9.3, let's say, considering that these all are running on different nodes, right? So this is your node A, and we have your node B, and that's your node C, right? So now we cannot give our users these IP addresses to access the application. That's just not what they want. And consider, like, we have a small application which spans across three nodes. Consider this a huge application that is distributed across 50 nodes, for example. So you cannot give 50 IP addresses to your user to access the application. That's not just a good practice, and that's not what they want. You need something as simple as myapp.com. which they can easily remember or through which they can access the application with just one single URL or subdomain if they want, but not something like these. So for that purpose, we use something called as load balancer, right? So load balancer will, what it will do, it will place this, yeah, I misspelled it. Just give me a second. Okay. So it will keep all these pods in the backend of this load balancer. So whenever user is accessing this application, they don't have to really access the separate IP addresses of the pods. They can just directly hit the load balancer URL, and load balancer, based on the load balancing algorithm, it will distribute the traffic across multiple pods. Right? But how does it work in Kubernetes? In Kubernetes, we actually create an external load balancer if you are using a cloud provider such as AWS, Azure, GCP. In that, you can provision an external load balancer, and then you can use a service type as load balancer inside Kubernetes, and it will refer to that load balancer, right? And it will do the thing for you. So, for example, if we go back to our cluster YAML. So let me just make a copy of it and I'll create a new YAML. So lb.yaml. Okay. And instead of, because we did not specify type at the time of cluster IP, but for now we actually have to. So inside spec, we specify type as load balancer with L capital and B capital and on a particular port, port 80. And service type should be load balancer. Let's give it a different name, LB. And again, we are using the same deployment to serve as the load balancer backend. And now if we apply the changes, kubectl create -f lb.yaml, it says the service already exists. I might have created it. So let me delete that first. Okay, let's apply it again. It's created. So kubectl get svc. Now we have lb-svc service created as load balancer type, and it does not have an external IP. Like, why does it does not have that external IP? This was our main purpose of using the load balancer, so that we can provide this as an IP address or as a DNS to the external users and they can use it, right? The reason why we don't have it, because we have not provisioned an external load balancer in this cluster. We created the service type as the load balancer, but we have not actually created the load balancer. So that is why it is there. If you are using a kind cluster, there actually is a way you can do that. If you go to this section, load balancer in the documentation, over here, it provides you a binary, cloud provider kind, which can be installed using Go, or you can download the release binaries from here. So this will provision a load balancer which simulates the actual load balancer in your system. And then when you create the service, it will listen on that load balancer. But for now, because we have not created a load balancer, and the reason why I'm not doing it, because it will just confuse you. I just don't want to go in depth of how kind works. And I just want to keep the focus on Kubernetes for now, right? So that is why I'm not doing it, but you can like feel free to try if you want. But for now, because we have not provisioned a load balancer, that is why it does not have an external IP, and that is why it is currently behaving as a NodePort service. So you see, there is a random NodePort that is allocated to this service. So this load balancer will be accessible on this particular port, right? This is load balancer. And now we have the last one. The last one is pretty simple, like if you have understood all of these three. So in last one, there is nothing different. So let me just go to service, and okay, over here we have already opened it. So go to service and then external name. In external name, if you see the YAML, we specify the type as external name instead of load balancer, and over here instead of labels, we actually map it to a DNS, right? For example, your database is listening on this particular DNS, so that's what we use as an external name. Now your internal services can refer to the DNS of your application. So this is why we use external name. It's Pretty straightforward. It's as per the naming convention. So I guess it should be clear. Now we have covered all the services and everything. Now there is one more thing that I wanted to cover is how do we do that in imperative way. So if we go to again the kubectl the quick start guide or the cheat sheet, earlier it used to call cheat sheet, but now they have replaced it with quick reference guide. So that is why you see it with the name quick reference. So if we go over here and look for expose or service. Okay, so this is how you can basically create a service from command line. Okay, so kubectl export, this is replication controller, but you can expose deployment, right? So kubectl expose deployment port and then target port. You can do that with the help of one single command instead of writing your own YAML. So try to practice this as well. It will be pretty handy in the exam so that you don't have to write the entire YAML. And I also wanted to cover namespaces in this video, but this video we have already covered so many things. So I think it will be better if we can do that in the next video. In the next video, we'll be covering multi-container pods, commands and arguments, and namespaces. So there's a lot again in the next video as well. So I hope this video was helpful to you. As always, I have also kept a small assignment for you in the GitHub repository of day 9. I guess this was day 9. Yes, in the day 9 folder. So check that out. Try to do that by yourself. Try to do the hands-on, and I'm sure you will find value in that. And if you have any question, you know how to reach out with the help of Discord server as well as comment section here. I will see you tomorrow with the next video. Make sure you like and share and comment on this video and hit the subscribe button if you haven't. And I will see you soon. Thank you so much for watching.